Hello, 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 everybody, and welcome back. We're looking at question number 2 on our 2010 Euclid math contest. Just like with question number 1, we've got an A, B, and a written C. So, part A. Maria has a red package, a green package, and a blue package. Might call them R, G, and B. Maybe use capital letters if we need to do something else with those. The sums of the masses of the three packages is 60 kilograms. The sum of the masses of the red and the green packages is 25. So I actually will make these letters the masses. And the sum of the masses of the green and blue packages is 50. What is the mass of the green package by itself in kilograms? Okay, so if I change my letters to represent the masses, we know that red and green and blue together is 60 kilograms. So this gives us one equation to work with. Red and green, 25. Green and blue, 50. Alright, we just want green by itself, which means we don't need to solve for red or blue, although I will do that in just a moment once I've got green. So the neat thing here is green appears in all the equations, whereas red only appears in the first two, and blue only appears in the first and third. Now you may have seen a question like this before or not. They tend to come up. They're sort of meant to be very basic, very easy questions, although you can find them with higher numbers for the question number on younger year contests. But usually we just sort of have to manipulate the expressions. Now there are several approaches. You could do something like rearrange this second equation to say green is 25 minus R, and then plug that into the third equation and relate R and B and things like that, and that's perfectly fine. I find the simpler thing to do, and it's a habit you sort of want to get into. If we just sort of line up the second and third equations, we can get an excess amount of green. So if we add both these equations, R plus, well, there's no R's down here, but then we get 2 greens and 1 blue, and that adds up to 75 kilograms. So the red, the green, the blue, and then another green gives us 75, but I know what red, green, and blue is on its own, and if I take that away, I get rid of the R's, get rid of the blues, and one of the greens will go away, and I'll just get green is 15 kilograms. Now, you write up whatever you need to, but remember, it is a light bulb question, so we just really care about the final answer. So, green weighing 15 kilograms is just fine. Now, knowing that, we can go back to the original expressions and, for example, take this second equation. Red plus green is 25. Well, if I know green is 15, red has got to be 10. Green and blue is 50. That second equation. From there, you'd get blue is 35. But again, there are likely no points awarded to figuring these out. It's really just, did you get 15? And if you didn't, show us a little bit of your technique for part marks. Alright, so that was A. How about B? A palindrome is a positive integer that is the same when read forwards or backwards. For example, 151 is a palindrome. What is the largest palindrome less than 200 that is the sum of 3 consecutive integers? Okay, sum of 3 consecutive integers. Now, if you don't know anything about the sum of 3 consecutive integers, and the thing we're really looking for here is that it's a multiple of 3, you can sort of start to set something up. You could say, well, I don't know what my palindrome is, but if it's the sum of 3 consecutive integers, then it looks like n plus 1 plus n plus 2. That's 3 consecutive integers, and I'm adding them up. And I get 3n plus 3. And I would say at this point, it's pretty clear this is 3 times some number. And in fact, if you have any multiple of 3, divide it by 3, and that number, plus the one above it, or sort of the next one, and the one previous, and then you get a nice sum. So for example, 60 is a multiple of 3, divided by 3 is 20. 60 is 19 plus 20 plus 21, a nice little sequence of consecutive numbers. So, what do I want? I want a palindrome less than 200. So, okay, if we have to be less than 200, then we're starting with a 1, at least I hope. So what are the palindromes less than 200? Well, there's 191, 181, 171, 161. They even mention 151, and we could keep going. We want the largest one that is a sum of 3 consecutive numbers. We want the largest one that is a multiple of 3. Now, you can either grab your calculator and try and divide each of these by 3, or you might remember divisibility rules. Divisibility rules say, well, the number is divisible by 3 if the sum of the digits is divisible by 3. So 191 not divisible by 3 because 11 isn't. How about 181? 1 plus 8 plus 1 is 10. No dice. But 1 plus 7 plus 1 is 9. 9 is a multiple of 3. 171 is a multiple of 3. I'll just quickly grab my calculator and figure out exactly what it is. But it's 57, so 56 plus 57 plus 58 is going to be 171. And there we go. So 171 is our final answer. And again, it's a light bulb question, so we would just bubble that in. That's all there is to it. So now C, our written portion. If x plus 1 times x minus 1 is 8, immediately I'm seeing that this is a difference of squares. It's a nice little factorization, good thing to be able to manipulate. So if that's 8, determine the numerical value of x squared plus x and x squared minus x. This is, again, another difference of squares. Okay. What can we do here? So, I might say something like by difference of squares or by expanding. We see 8 is x plus 1 times x minus 1 is x squared minus 1. And so x squared has to be equal to 9. Now, you can go from there and say, well, aha, x is 3 or minus 3, although I don't necessarily know that we need to know what x is right now. Because what are we asked to compute? X squared plus x times x squared minus x. And again, difference of squares tells me that's going to be x to the 4 minus x squared. In general, difference of squares, and it's not something particularly special, just sort of a shortcut when it comes to factoring. Anytime you have an a minus a b and an a plus that same b, you multiply them together, you get a squared minus b squared, a difference of squares. Okay? It's a nice little shortcut to know. But, of course, you could expand things out and cancel out the positive and negative terms, and that's fine too. But this saves you a little bit of time. But now, what have we got here? I need to know x to the 4 and x squared. Well, x to the 4 is just x squared squared. And then we've got x squared, but I know what x squared is. So I don't actually need to figure out what x is. It could be either 3 or negative 3. It doesn't matter. So we'll get 9 squared minus 9. And so this is 81 minus 9. There's not a whole lot to this question, so I am trying to write out my steps, but we get our final answer of 72. So what's going on here? It's a written question. I've explained my expansion, so I don't actually have to show my work for the expansion. Difference of squares. And then I point out x squared is 9. I expand the expression they want me to use. I show how the 9 fits in, specifically here where I do x squared squared. And then 81 minus 9, that's all there is to it. Okay? And that does it for question number 2. Up next, of course, question number 3. I will see you there.